There are three types of programming paradigm. If you don't know the meaning of word paradigm is a thought process, a mental model that you apply when you want to any concept. And programming paradigm specifically talks about what should be the thought process as you are building application. And the first paradigm that we're going to talk about is the structured programming. So if I can bring back some of the memories of the microprocessor that we saw, we had multiple instructions like move AX and 10, and then move BX as 20, for example, and then an add instruction. So this is like a simple looking program. But then there were at least two more instructions that would change the flow or the course of the application. And then to draw parallel between, to recollect one more point, that this is always going to get pointed by the CS and IP, the code segment and the instruction pointer register. And in this register, whatever value it holds, that instruction is going to get executed. So, uh, so as your application size grow, you would want to have some form of modularity in your application. And this modularity, to achieve this modularity, there are two more instructions. One is call, and then call is going to take an address, and the other instruction is jump. Jump has multiple mnemonics. Like jump is, this one is an unconditional jump. You can give it an address and it is going to change or influence the value of code segment in IP register, and the code after that is going to jump to that specific instruction. But you can also have other jump statement, like jump if it is not equal to a specific address. If they are equal, then you jump to a different address. So jump has multiple variants. Some are conditional, some are non-conditional. And then each of these instructions, depending on the address that you provide to it, it is going to change the course or change the flow of an application. So each jump instruction is going to affect where the code is going to go next. So this CS and IP register is going to get influenced by these three statements. Now, uh, the problem with this is that what we have seen in our previous sections, that code segment, there's a code segment, there's a data segment, and there's a stack segment. When you know where you want to return back, right, your application will have a sense of control to it. So if this call statement belongs to a function, that function is going to perform some operation for us, and it is going to return the result. Now the result itself is going to go and sit in some register in the processor, but then this return instruction is going to instruct the processor or the operating system or the program loader that there is an address saved on the stack, and then that address belongs to these three circles. So it goes ahead and it pops everything from the stack until it gets that address, and then when that address changes, it restores the value of CS and IP to those three circles. And because of this, the regular program flow where we started probably with the main function, alright, it is going to resume. So it is going to make a call, it is going to change CS and IP, it is going to go to a specific code segment, it's going to run that code, it's going to come back and resume the regular flow. But then with jump instruction, there is nothing that goes in the stack segment. So when you make that jump, your CS and IP is kind of stuck, and you have no easy way of tracking that back. What you can do is in the beginning of this thing, you do some move instruction and you try to save the address of this particular location and in this particular variable, right? If you do that, that will become a very manual work, and understanding those applications is going to become extremely challenging. So the structured programming paradigm, it suggests that your application should not do unconditional code flow. So as you are building complex application, your application is going to have multiple lines of code, and these lines of code, they are supposed to be executed in a controlled way. And if you use jump instruction, your application is going to be very difficult to write, very difficult to maintain, and very difficult to understand. And all of those problems arises in the assembly language because of jump instruction, and in the higher level languages because of the goto statement. So goto statement is present in multiple form in all the languages. Right, goto statements is present in multiple higher level languages in different forms, but then their usage is highly discouraged. Right, so the structured programming paradigm is not a positive statement that says that, hey, use this and this is how you should write program. It is a negative statement, and it says that you should not use unconditional jump in your code. Right, so it does not recommend anything, but then in our application we have code construct, code building blocks, which we call control flow statements. So these control flow statements, they are more or less like this: if else, uh, for, while, and then function calls. I won't call function call a control flow statement, but instead of goto, you should rely on these or a combination of these control flow statements. Right. So once again, structured programming is avoid using goto statement. Now let's jump to the second part. So generally, object-oriented programming is defined with four different pillars. I put abstraction and encapsulation together because it is really difficult to separate abstraction and encapsulation. Once you do one, the second one automatically happens. Then next is polymorphism, and the last one is inheritance. We saw an example of all of these in the last week. And then if you are a C programming expert, if you understand two concepts in C programming, like structs and pointers, right? Using these two uh, constructs of the C programming language, you will be able to achieve at least three of them to 100%, and at least one to about 50%. So what you can achieve is abstraction and encapsulation and inheritance. And the way, so if you've done a lot of C programming, you would remember that there are .header files and .c files. That's how it is in C++ as well. There is a header file and there is a CPP file. The header file, it only tells you the definition of those functions, that this particular class, it looks like this. This particular, I'm so sorry, not a class. This particular function is going to have this kind of signature. And the implementation details, they are kind of abstracted away, hidden away from the actual consumers of it. The way we consume these files is using hash include statements, and we are going to include those header files. But in .NET, there's no header file. All we do is we put a using statement using say system, right? And system is an assembly, and it has the actual implementation of those functionality that we are trying to utilize defined in another file. Right? So abstraction and encapsulation, they are kind of very partially implemented or taken away because of these kind of programming constructs in higher level, or at least frameworks like .NET. Inheritance is something that you can have in C programming using the struct concept. You will have to declare variable in a little tricky way. It is not that you are going to use the actual inheritance construct, that the child class is going to be on the left, you use a colon sign, and then you put a parent. But then the way you declare your struct variable in C program, that at the end of it you can leave some tricky C statements that is going to give you the same implementation or same feel as inheritance. The only point that where object-oriented wins is where polymorphism comes in picture. And if you remember our example from yesterday or the last week, where we talked about how parent and child and virtual and abstract function work, you are going to start appreciating this diagram more. So a C program or a structured program, it generally has a common starting point, right? And this starting point is going to go deeper and deeper with each layer of functionality that we add. So this is the main function. These are some of the functions that the main function is calling. So the main function would have, say, if I call it function 1, function 2, function 3, the main function is going to look like function 1 and the call statement, and then function 2, the call statement, and function 3 and the call statements. And then these indirect functions, they are also going to look the same, right? If you have any reason for changing or upgrading or switching, the change is going to trickle down from the beginning. Let's assume that function 1 is connecting to a SQL database, right? And you don't want that. You want to switch to, say, Neo4j, a graph database, because you have figured out a new way of working. Then everything on this chain is going to get affected, and the change is going to go as up in the chain as the main function itself, right? You will have to change, you'll have to replace f1 with, say, another function, which is f4, and then f4 is going to be that new component which is going to handle the Neo4j code. And then it can have its own subcomponent where it is doing Neo4j specific or graph database specific activities. The only problem is that there is no easy way of not letting the main function stay the three function calls like f1, f2, f3. F1 is going to do database activity, f2 is going to do some reporting, and f3 is going to do some UI designing, right, or UI drawing on it on the screens. Structured programming does not give you that flexibility. Structured programming is, if you want to change something, you will have to start the change from the beginning, and this is where the wiring is going to happen, this is where the function calls are going to happen, and accommodating changes is not very straightforward. And this is where polymorphism and object-oriented programming, they kind of start winning. So the diagram, I'm only going to draw like 3 blocks this time. What object-oriented programming offers through polymorphism is that the main function, instead of depending on the function itself, it is going to depend on an object. I'm so sorry, it is not going to depend on an object, it is going to depend on an implementation, an interface, an abstraction. So if I want to write a function called f1, I'm going to create an interface or an abstract class. I'm going to call it, say, if1, and this if1 is going to use implementation, and it is going to provide the concrete implementation of f1. And the code inside the main function is going to look like, say, I'm not going to use var here, I'm going to say if1 obj assigned to somebody give me an object that is getting implemented using if1 class, right? So this class name here is representing a class that is implementing or inheriting this particular interface, and the actual code itself is going to look like obj that do something, and then this function is going to, this interface will be inheriting from this abstraction, and it is going to provide the actual implementation of do something. So the actual activity of the actual work is going to be done in a class that the main function is not even aware of, right? Where we get the subject from is going to influence what kind of flow will be taken. And then if I can tell you the actual terminology for this, right? Everything that sits on this side is called policy. And then everything that sits on this side, it is called details or implementations, right? So object-oriented programming, they have flipped the order in which the main controls the execution of an application, right? It is in the structured programming, it goes from, it flows from the main function and it starts working down towards other functions, right? In object-oriented programming, it starts at main, but then the dependency is kind of inverted. Instead of depending on concrete implementation of those functions or those functionalities, it depends on abstractions. So if I have to give a different definition of, excuse me, if I have to give a different definition of object-oriented programming, I will not use these four pillars I'm not going to say that it is abstraction, encapsulation, polymorphism, and inheritance. Object-oriented programming is the ability of using polymorphism so that you gain control over which objects, which source code gets executed, right? The details, they are going to be hidden from the main function because of this structure. It is the way we are using polymorphism, right? So once again, object-oriented programming is so the paradigm itself, object-oriented programming, is not a positive statement that this is how you should be calling code. It is once again a negative statement that says that your code should not depend on concrete implementation. Right? As long as you have a mechanism of disconnecting the policy from the detail, right, you are doing object-oriented programming the right way. Right? You are not to depend on concrete implementation of classes. So that is object-oriented programming. And then the third programming type is the functional programming paradigm. So it is functional programming paradigm. So in functional programming, as we write applications, there are two things that we're going to do. We're going to declare variables like x is assigned to 10, and as the application progresses, we are going to modify the value of this particular variable. So x after this line is going to become 11. There are multiple activities that is going to influence the value of x itself. Right? So after this, it's going to become probably 121. The functional programming paradigm says that you should avoid two operations. You should avoid the update statement itself. So once you are given a memory location, you do not modify the same memory location twice. That is requirement number. That's one of those two requirements. The second requirement of functional programming is idempotency. I'm sorry about that. So there is something called as idempotency, and it it means that when you call a function, it should always give the same result. Now I'm going to show you an example of at least two functions where the value is going to be different with every call. So if you want to calculate date of birth, what you would accept is, if you want to calculate age, you will accept the date of birth. Right? I'm going to call it DOB for short. And if you want to calculate age, you're going to do return datetime.now, which is going to give you the current time instance minus the date of birth. This function is probably going to give you count of days or whatever. It's going to give you, say, a time lapse, that how much time has elapsed since your date of birth. And this function, with each call for the same input, is going to give you a different output. Now if you compare this with a function like square, every time you pass it the same input, it's going to give you the same output. So functional programming says that all of your functions should be like this. With the same input, it should always give you the same output. Right? This function is a little tricky. When even when you set the input as same, like somebody's born in 1990, this function every second is going to give you a different output. Make sense? So functional programming discourages this kind of programming, and it encourages this kind of programming. And it is going to be a functional program if your program is doing this. So item potency is the first aspect, and the second is that you do not modify the same memory location twice. We're going to look at threading and parallel programming in a few coming days, and you're going to realize that when you create a resource like this, so I'm calling a memory a resource because memory is one of the resources. The other resources are, say, I/O devices, input/output devices, and network is another. So network falls in the category of I/O as well. But then memory is one resource, and input/output devices are another uh, another resource. Um, this is, for some reason, has been used to indicate threads. Uh, threads. So these threads, they are parallel execution uh, of inside the processor, and the processor switches between these threads. When I declare a variable like this, which is a memory resource, and assign a value 10, if this thread tries to put a value 20 and this thread tries to put a value 30 on the same memory location, your application runs into something called as a race condition. Now, a race condition is competing for the same resource. When two applications tries to modify the same location, the output is unpredictable. Depending on what the operating system decides, that if I want to execute thread 1 or thread 2, if thread 1 executes first, it's going to get 20. After that, thread 2 is going to come and modify 30. Now, these threads can indicate you trying to deposit money from the bank, and then somebody is withdrawing a check that you have issued. If you're lucky, your balance is going to be more than what it should be. If you're unlucky, your balance is going to be way less than what it should be. Right? And all of that happens because you are trying to modify, or there are competing parties involved in an application that are trying to modify the same memory location. So what functional programming says is that once you have a memory location, you should not modify it. And with that, your account balance is not a memory block anymore, which is storing a value X in it. Your account balance, it becomes a series of transactions that happen in your account. So you open your account with, say, $100 in it. Then somebody deposited another $200 in it. Then you withdrew about $100 once again. When somebody comes and asks me, hey, what is the account balance of, say, account number 101? I'm going to do the math on all these numbers, and the addition at the end of this is going to give me 200 once again. So I'm not going to store 200. I'm going to store the transactions that happened on your account. And these transactions, every time somebody comes and asks me account balance, I'm going to perform arithmetic on this balance and I'm going to give it to you. So that way, if these two threads, one is trying to withdraw and one is trying to deposit, they are going to leave their own effect in the application. And these are like just insert statement inside a list. Okay, and I'm jumping ahead of myself, but then we saw multiple type of list and stack and data structures yesterday. There is something called as thread safe list. Uh, I think it is called concurrent list. So concurrent list is going to disallow insertion from multiple entities, or there are ways in which it can be synchronized. So this synchronization is going to help maintain the integrity of the account insertions. So it is never going to delete or modify your old balance to reflect the new balance. It is going to store the transactions that are being performed in your code. And then through this, we are never going to run into a race condition. And then, so this is once again a negative statement that says it does not dictate that this is how you do functional programming. It tells you that things that you should not be doing. Your function should always return the same output, and you should never modify the same memory location twice. And then if you understand this, a lot of code that we have been writing so far using the for block, the while loop block, inserting members to add, calling the dot add function, dot remove function from a collection, all of those theory, they kind of blow up in our face. All of our programs that we have been writing so far, they are not functional anymore. So functional programming dictates that you use idempotency and you do not modify memory locations twice. So with this, let's jump into the